Everyone, I know it's after lunch. My name is Theresho. I'm a software architect from BMW IT Hub. Okay. I had a dream, and I still have a dream where AI runs everything, a dream where AI takes over testing, right? A dream where we no longer worry about or testing slowing us down, a dream where pipelines run smoothly. And that dream is what we call autonomous testing. This is a world where you truly can set it and forget it. In case you're not aware of what autonomous testing is, we're talking about a few test processes that are actually self-adapting. Okay. Now that's a story I want to share with you today. My journey towards making that dream a reality. Genesis 2013. As a young developer working on a project with quantitative analysts, this is back in the banks, we had this massive data sets that we had to use to test our rules against. And instead of a testing team, all we had was a spare laptop, a few late nights, and some stubbornness. So what we did is we built this Java application, wired it up with Apache Poi. I don't know if there are any Java developers here. And then added some conditional formatting on the results. So essentially what you end up with is an end script that orchestrates everything, that executes the tests against these rules, spits out the results, do all the comparisons, and create all this fancy Excel sheet with formatted or conditional formatting. Eventually, we leveled up with Jenkins, of course, to move the pipeline there. And at the time, this was revolutionary. Now, fast forward to today, we live in a world where code goes straight into production. We have a term for this, it's continuous deployment. But once things have changed and evolved in all these IT spaces, there is this feeling that one thing was left behind, and this is testing. The reason testing is left behind is because development space have actually moved forward, where we now leverage config-driven development and low-code platforms to rapidly build applications, business applications on. We also have these continuous pipelines or these continuous deployment pipelines that bring code very quickly to production. Now, our lovely testers are left behind trying to play catch up. Okay. But how do we catch up? So, of course, vision alone is not enough. And we need to get started slowly in some way or the other. But the first question has always been, how do we make sure we select the right tools? So this is a framework, a little framework that helped us or helped me in the various projects I worked in. And the first one has always focused more on scalability. How can we grow as the application evolves and grows? How do we grow also the platform for testing? The second one is more focused on how do we ensure that the people or the testers and developers are not becoming tool operators, where they're spending so much time trying to just basically get the next pipeline on this tool or write the next script on this tool and making it so much about the tool and forgetting the real value behind it. The third one, which brings us more into autonomous testing, which is basically impossible to achieve without, is the leverage of AI. I know, of course, everyone is talking about AI today. But one of the main things also to consider is what is the learning curve? What skills and resources have you got in the company? And what would it take us to achieve that? Because as I've mentioned, if you have the vision and no means to achieve it, then it's just a dream that can never become true. Okay. So config-driven execution of our tests is a basis or the foundation for this autonomous testing. And I'll dive deeper into that hopefully as we go along. But with AI assisted models or with AI assisted adaptation of the tests, we achieve the true state where we can set it and forget it. Okay. Now, just touching into one of our tools, right? I've presented this already on one of the conferences previously. So some of you may have seen some bits of this code, or some may have actually interacted with it. But this is one of the custom tools that we had to build. And this was built on Java. You can see there's some form of templating there. Of course, these variables are then replaced with the real values at runtime. The reason for this is so that you are able to execute the test with repeatability. So you can execute the test multiple times without the previous state affecting the next state. Okay. We, of course, have to keep state somewhere to know which sequences have already been used or where we are on the sequence so you can generate the next number. Okay. So we had then sorry, just to go back, we had a Lambda function that is able to also give you everything that you need. So this is basically the generation of the different patterns based on the shape of the values that you're trying to create so that you don't fail schema validations if you have such. And then, of course, JUnit to dynamically generate the tests. If you look more on the left, you can see that there are files with a certain structure, and this is pretty much just configuring what must happen, as opposed to writing the code and the entire. So the code is pretty dynamic, and you just give it the part that that is specific so that it executes it. Okay. With such frameworks that are more config driven, you are actually able to catch up. But most importantly, you're also able to get some AI assistance with a little bit of precision to get more desirable results. If you've worked with ML and anomaly detection, those kind of things, you know that sometimes it could miss the spot. It wasn't always that easy. So the road is always bumpy, right? And of course, there have been some challenges that we had to overcome. One of the challenges and the biggest challenge that you'll find, especially when you're trying to do something very evolutionary or something that is a bit unfamiliar, you'll have some skepticism from the team. And of course, you have to overcome that. Buy-in is very important for any tool that you introduce. I don't think I have to mention that. I'm sure each one of us here have had some experiences where you have the best tool in the world and you try to introduce it and no one wants to use it. Okay. It doesn't really matter how much value the tool or potential the tool has. If you don't get buy-in from the relevant stakeholders, you're not going to effectively be able to implement it. Okay. Now we also have resource limitations. So sometimes you have the right resources, just doesn't match the skills. Therefore, you have to embark on this journey of learning. So the learning curve was actually quite steep, specifically for me, in the field of AI. Now, we have had all of these kind of issues where we had to deal with flaky tests, which we have all these experience with. We've also had cases where we have this brittle test that you touch one small little thing, the whole framework falls off, and you had to move from that into trusted pipelines. The deployments are much more smoother, safer, and faster with config-driven testing. So this is a journey that we had to embark on, and this is something that we have to continuously improve on. Okay. And most importantly, our developers are seeing testing more as a partner, as opposed to all these little things that they have to do after they've done the real work just to satisfy a requirement. It's no longer such an obstacle. So that buy-in was quite important, and bringing this config driven or these concepts that developers are already familiar with closer into the testing space also allows for that easier buy-in. Now, what is ahead of us? Of course, we are not anywhere close to the end. If we look at what we've achieved so far, we are able to execute tests. Because everything is config driven, You're also able to generate some tests through some form of smart generation tools. In previous talks, I've spoken about how these tests are generated. Currently, that's what we do. We also have concepts such as server-side test recording, and of course, the most popular client-side test recording, where you're able to record the activity that you generally do manually and be able to repeat it. In order for you to repeat it, mind you, you have to ensure that your data changes, or at least the previous state is not impacted by the other one. You could do it the more expensive route, where you wipe out the entire database and reset the state and start with new state, or you could have leverage such tools as Ginjava or Jinja for Python, where you are able to then pass in some expressions and have those replaced with real values at execution time. Okay. But all this is nice and fancy, and this is what is helping us today. But we have still not achieved the state of autonomous testing, because we still have to write and configure these tests. We still have to adapt them each time requirements change, which will change every time, right? Because we're in business and we have to stay competitive. So the development teams will always also try to adapt based on regulations, based on competitive advantage or taking advantage of opportunities in the market, etc. And we need to keep up and be able to also just as quickly be able to configure these tests. Now, if we still have to configure it, have we truly then, have we truly being able to implement continuous deployments? So in order for us to have continuous deployments, you have to fully automate your testing. So if you're not automating your testing, it means that you have to, at some point, implement some manual intervention, right? So what we would like to do now is to almost phase out the element of having to configure the tests. Right now, the developer can work on the code and the test at the same time, implement some nice behaviors like behavior-driven development and test-driven development, because the tests are closer to the code. So that's all lovely, and you could do that. But what if you could actually almost forget about, because the developer could still misinterpret the requirement. But the developer could also just miss it and decide, maybe one rebel decides not to write the test at all. So what if you had this process that allows for the test to be generated before you even start working? Because all you need really to write the test is the requirements. Okay. So if your requirements are already structured with tools such as X-Ray, tools that allow you, I think there are a lot of other tools that where you can have a test repository, which basically gives you a test suite that you can execute each time for regression purposes. If you are able to execute such, you are now in a position where you can basically have this AI learn how to generate the tests in a more structured manner, because the rules are well defined. You can teach it the rules so that when it generates the test from the requirement, it's able to actually understand how the requirements, so how to generate the test most importantly, and also how the requirements are structured so that it generates something more accurate. Okay. So this is very important if you're really going to increase the confidence levels of the test generated by an AI. Yeah. So what lies ahead of us is having this adaptive test generation. So you allow the AI not to just help you know when tests break or when things are going to break, but to truly generate the test that is executable without intervention from the user. Okay. The next thing that you have to think about now is what happens if the test fails? The infrastructure could fail, or it could be that the test has become redundant and it needs to be adapted. It needs to be changed. You could run some predictive analysis, not just on the code, but also on the tests to see if anything in the framework or in the test suite needs to be adjusted. So this is also another case when AI can actually take that away from the developers or away from the testers. Okay. Now, you also have to be able to tell when something is not working, when something is not valid against the requirement. You could build the best software that does not meet the requirement. Therefore, there's no value in shipping it into production. So you need some form of quality gates. Now, for continuous deployments, in order for this testing to not become an obstacle, you need to be able to automate your quality gates. So now this, of course, you can do with or without AI, but it always helps if you are also able to govern those and have them almost update in a more autonomous way. So this means that you're implementing your AI learnings on three different stages of your test or three different pillars of your test automation. Now, this helps you to achieve what we call autonomous test automation. Okay. I'm going to circle back to the lessons learned throughout this journey. And I was hoping to have more of an interaction. So I hope we've been listening and we have some questions around this so that we are able to also get some great ideas because this is actually something that would it's not very popular, so it would be something that would also help the future in general. Okay, so the first thing is you have to bake in testability in your application. Okay, now what does this mean? We have this framework, which I will not display here. I have not prepared the slides for, where we've recently worked on this tooling for user acceptance testing. And the way that we come about to implement this tool or to design this tool is we literally followed the same pattern. We check, is it scalable? What would be the tool for manual, so for, that will be more maintainable, and how would we integrate AI? So with all of those elements taken into consideration, we picked up that the tools available for us on the market are not good enough, but we also don't want to reinvent the wheel. So what we'll do is we'll bake into the application traceability, which is a concept that you need in any case for observability. And through that, implement a tool that understands all these trace logs and is able to tell and apply some form of assertions. Now, if you apply assertions, you already know I'm talking about testing or some form of validation. So this is a tool that you are able to run almost standalone as an application and can actually configure to run as a black box because you can just pass in some input and expect some output. But because it's also based on some trace logs, etc., it allows you to have some deeper look into the application. Of course, this is something that you can only achieve if you still need some context on the application. So you have to work very closely with your development team. Not to mention that from the design phase, you need to bake in how you're going to expose those metrics within your application. Now, the reason some of the APM tools seem to not work for us is because we let the tool just do some magical generic metrics. So we have to think about how we're going to generate our logs. So at a level, at the so the framework that you use for logging and how structured or unstructured your logs will be, what kind of details and information is required in each of the logs, and what kind of dimensions are you interested in to slice your logs so that you're able to make sense of them. So this is information that is particularly interesting for any application, in any case for operability. But this is also useful information for us because we are able to adapt this and make it useful for our assertions. Okay. So this is one way of ensuring that you are able to still achieve some level of automation without having to build something new each time, because these are very structured ways that you can easily teach to an LLM, most likely even get away without having an LLM and still have your test more adaptive. Okay. Sorry. Then the second one that I've not touched on is you should never fear unpopular approaches. The reason I mention this is because there is no way that you're going to innovate if you're just following the world. You really need to be curious and question things. We've been doing testing a certain way for quite some time, and understandably so. Most testers are very helpless when it comes to writing tools that help them, but we rather focus on what tool can I use to implement the best automation. We need to focus more on working closely together with the development team as a software development team with almost cross so with basically all the different functions or cross-functional teams so that we are able to get the best results out of it. The reason this is important is because you end up with developers or with testers that are frustrated because of the test tools that are available, and they can only work with the limitations and make that normal. So you normalize that instead of adjusting and making those something or changing it into something that makes sense. Now, we also realize that developers and testers don't really get along, not all the time, at the very least. So that makes it difficult for developers to also learn, to develop testing tools. So you are left with basically SmartBear and some of the other corporate companies that are going to build tools and sell it, and you just have to work with what they provide. So it's important that we are able to work closely together with our developers so that they can actually have an impact in also bringing the test tools closer to where the world is going. Okay. Then the next thing is, I've already touched on this one, but it's just as important to get buy-in and develop the right testing culture in your teams as it is to have the good tools. So you don't want to have all the great tools in the world and end up with a team that is not able to test effectively because each person is running in silos or is working in isolation and they are not able to work with the other team. So it's important that you develop the right culture, that testing is baked in from architecture, from design. So when you design your application, that it's baked in from when you start your development processes, and that it's also baked in the end in the CI/CD pipeline, so the integration of your code all the way into production. So if you're not able to achieve something as simple as that, then the best tools will basically just be tools that will execute and of course take up, because AI is sometimes a bit expensive and it will take up processing power, but it will not have an impact or have that effect that you're hoping for. Okay. Now, of course, this can be, if especially if you are still in a place where you're doing manual testing, it could be a bit overwhelming. It's a lot to adjust, and you can't go and change everything all at once. So I'll suggest that you always start small. Take your different iterations. Do not be content with what you have in that small little setup. You want to be able to take multiple iterations over your process. See, what can I improve? This broke last time, so how can I make sure it doesn't? And that way you improve it to become something that you always want to achieve. Now, also think about how you scale that. Okay. Because you're not always going to implement the automation in every sphere of your application or your system all at once. You started small, you implement it in the parts that you are able to, iterate on it to improve it to a stable level, and then start scaling that. So that means you are able to cover a lot more with something more robust and ensure that as we ship things and code, we make deployments probably daily, a couple of times in a day. And this is basically becoming more and more normal for most organizations from a software delivery perspective. But from a testing perspective, we still have quite a number of manual processes within our testing spaces. We need to be thinking about how do we ensure that we have more efficient testing? How do we measure our coverage at different levels, your test coverage from a requirements coverage perspective, and also from your code level perspective. But if you're not able to buy back that time, then you'll be left behind basically just trying to catch and test the more critical parts of your system. And of course, it will break and you'll have to test also the hotfix. Okay. So now, if you think back in 2013, my dream was just as simple as running a job on Jenkins, right? I just wanted to have a place where I can automate this test process because it's quite a number of data, a lot of data, and we had to generate this report. Well, we had a beautiful thing going with this spare laptop where we could run this number of test cases, etc., and generate some reports and throw them back at the quants. But what if the quality gate wasn't a person on the other side? What if the quality gate was, you know, automate it. So what we ended up with today is we have this AI-driven pipelines, or at the very least, this config-driven testing that is in place. And today the dream is AI-driven testing, autonomous test automation, but in future it could be something else. So the important thing here is we must keep dreaming. And most importantly, build those dreams into reality. I thank you. Now, are there any questions? Yes.
Hi, Theresho. Thank you for the very detailed talk. One of the things that stood out for me is you mentioned you deploy to production daily. So does that mean in your workflow with these autonomous testing tools that you have in place that you've eliminated the need for cycles in testing environments?
Yes. So that is correct. I've mentioned that it's important to have a good foundation. And if our application, just to give more context, our application is also config driven. So 100% of our business cases are in configuration. So 100% of the business rules are in configuration. So that means it's quite easy to rapidly get a deployment or to get a business use case completed. We spend more time in the testing phase than in the actual development of the requirement. So in order for you to be able to achieve that, we had to move to config-driven development, so testing as well. So now we've moved our testing to, this is screenshots of real tests from our environment. And we had to move to a place where you are able to also configure the test as you configure your use case, which makes it easy for us to execute those on the pipelines. Of course, then with assertions that we get out of the box with JUnit and the test reporting that we get out of the box from JUnit, because we didn't rewrite everything, we just added some sugar on top of it, as we used to call it. So that means you are able to then just execute the test, which dynamically generate the test using JUnit 5. It has this feature. And for each of the tests that we execute, we run their sessions against JSON schema validations. So the application is configured, and as you configure it, we also generate schemas at a field level. So we know what the shape of the input and the output should look like. So we are able to use the schema then to validate against the request and the response and ensure that the application responded with the correct values. So that executes on our CI/CD pipeline. And if this, we've got about 800 odd tests last time I checked, running on that pipeline for the systems. And as the system grows, this also expands. We're executing this. We use the same framework on two different types of changes, but they execute against the same system. And this, as soon as this basically gives you the okay, we shipped, it's fairly safe for us to ship directly to production. Of course, every now and again, there'll be some defects that creep in because it's not covered in the test, but that's normal, whether you test manually or you automate it.
All right, thank you.
Yeah. Is there a question? No question.
Thank you very much.